the next module of stationary waves. In this module, we are going to study the last module of concept of string and the MCQs which are based on it. So to understand this module, let us go ahead to the very first problem which is given to us. The problem says the length of the sonometer wire is doubled and the tension is increased 4 times. Now length of the sonometer wire is doubled and tension is increased 4 times. What will be the frequency? Now frequency has been given few options. Let us see what are the options given. It says it will become twice. Option B says it will be reduced to 1/2. Option C says it will remain the same. And option D says it will become 1/3. To move ahead, let us see what is given. I know that n is equal to 1 upon 2l in bracket under root of t by m, which is multiplied to it. To solve this problem, I know that tension, length and frequency are related. So if I have to find out the relation, it will be n, which is directly proportional to root t by l, since m is constant and 2 is also constant. To move ahead to solve the problem, I know that n1 by n2, which is equal to l2 by l1 multiplied by under root of t1 by t2. I know that the final length is doubled, so it will be twice of L1, and final tension is 4 times the original, so it will be 4T1. On substituting L2 and T2, I get 2L1 by L1 multiplied by square root of T1 by 4T1. On solving this, I get 2 multiplied by square root of 1 by 4, which comes out to be 1 by 2 into 2, which is actually 1. So can I say N1 is equal to N2? That means the frequency will remain the same. Hence option C is the correct option in this case. Moving ahead to the next problem, it says if there is a sonometer wire of length L1, it is in resonance with a frequency 250 Hz. So frequency is given for the case of L1. So can I say this frequency is the first frequency? So I will call it as N1. If the length of the wire is increased, then 2 beats per second are heard. So can I say length of the wire is increased, then the frequency must decrease, and the beats heard per second are 2 beats per second. What is the ratio of the length of the wire? So you need to find out the ratio of the length. I know that n directly proportional to 1 upon L. Now frequency is inversely proportional to L. That means if the length increases, then the frequency decreases. So I can say N1 by N2 will actually be L2 by L1. Now we need to remember this. N1 I can say is the original frequency, and N2, since the frequency is decreasing, it has to be N minus 2. That means 2 beats per second are heard, so this has to be a frequency less than 2. In the second case, L2 by L1 is going to be as it is. I know that the frequency of original was 250 Hz. Now in the second case, N minus 2 will be 250 minus 2, that is 248. So it is 250 divided by 248, which is L2 by L1. So can I say it is 125 by 124, which is L2 by L1, and this is the option C. So students, with the help of this, we understood how to find out the ratio of the lengths of the wire when you have been provided with the frequency, and in the second case you have been provided with the beats per second. Moving ahead to the next problem, it says a transverse disturbance, that means a wave, is sent along a sonometer wire of length 1 meter. So the length of 1 meter is given to you. The linear density, that is the small m, is given to you as 0.25 gram per meter. It is stretched with a tension of 10 Newton. So tension is given as 10 Newton. What is the time taken by the transverse disturbance, that is the wave, to travel along the wire? Now to find out the time taken by the disturbance to travel along the wire, how will I approach the problem? Students, I know that in this case I need to know the velocity. So velocity of the wire is given by V is equal to under root of T by M. Now this is the velocity of the wave on that wire. So I have the tension, I also have the linear density. On substituting that, I get 10 divided by 25 into 10 to the power minus 5. You must be wondering how I got this 10 to the power minus 5. Students, in the above question, the unit is in gram. That is why it will be multiplied by 10 to the power minus 3, and since it was 0.25 by converting into 25, it is 10 raised to minus 2 extra. So 10 to the power minus 5 will come out by the multiplication of 10 to the power minus 3 multiplied by 10 to the power minus 2. So you got this velocity, which finally comes out to be 200 meters per second. Now what is the question that you need to determine? I need to determine the time taken by the transverse disturbance to travel along the wire. The time taken will be given by the distance divided by the velocity. The distance is 1 meter, the velocity is 200, so 1 upon 200 is the correct option, that is option A. So students, with the help of this module, we actually understood how to solve the problems which are based on the concept of string. Thank you.